This is activity 2, telling temperatures for lesson 1, number puzzles. And in this puzzle, we're going to do number 1 first. You have to find out where this temperature starts. What's the starting temperature after several steps? I'm going to make a rough drawing of what's going on. And this is just a way of getting me into thinking about the problem, just a rough draft. And so I'm going to start at 0, and it says the temperature is very cold. Then the temperature doubled. Well, the temperature is very cold. I don't know if that's a positive temperature, I don't know, or a negative temperature. I don't know if it's above 0 or below 0. All I know is that it is cold. So cold means different things to different people. So this could be positive 25 degrees. That could be cold to people that live in Southern California, or a negative 15 degrees, which would be cold to people that live in Alaska. So you just don't know. So you just have to start somewhere. And then that temperature gets doubled. And then the temperature drops by 10 degrees. So now I can actually put a number here and just draw an arrow, and I'm going to call that 10 degrees, negative 10 degrees. I don't know where it starts, and I don't really know where it ends. It's just 10 degrees lower than whatever this point is right here. Then the temperature increases by 40 degrees. Now you add 40 degrees, and now I know where it ends. It ends at 16 degrees. So the temperature is now a positive 16 degrees. So now I can retrace my steps, and I can get back to this point right here, because if I added 40 degrees to get to 16 degrees, I just subtract that 40 degrees. So what's this temperature right here? It is 16 degrees minus 40 degrees, or plus a negative 40 degrees. And this is now negative 24 degrees. So how did I get here? Well, I added a negative 10 degrees to get to here. So now if I just add that 10 degrees back, so now I'm going to add a positive 10 degrees to get back to this point right here. Oh, I don't know. Actually, all right, so that's why this is a rough draft. So I'm just trying to get an idea. So negative 24 degrees, so I have to add 10 degrees to get back to this point, which is at negative 14 degrees. So this is probably good enough for me to make a better drawing and to figure out where this temperature starts. So on the next page, this is really the same drawing. So the temperature gets doubled, add a negative 10 degrees, add 40 degrees, and you end up at a positive 16 degrees. So those steps are outlined right here. Now if you retrace your steps, and so you're going to start at a positive 16 degrees, and I'm going to subtract that 40 degrees. I added 40 degrees, now I'm going to subtract that 40 degrees, and you end up at a negative 24 degrees. So now I added 10 degrees. Here I added a negative 10 degrees, so I have to add 10 degrees to get back to this point right here. So this point right here is going to be a negative 14 degrees. And what happens to that negative 14 degrees? That is the result of doubling the beginning temperature. So you have to cut that temperature in half. So I have to cut this in half to get to here. So negative 14 degrees divided by 2. Cutting it in half, taking half of it, dividing it by 2, that equals a negative 7 degrees. So this is the start. So this temperature right here is a negative 7 degrees. So if you look, my arrow is going in the wrong direction. That's okay. Now I can just redraw it and redraw it correctly. I know that this first step now is a negative 7 degrees. That's the start. And my reason for doing this is to show you my thinking as I go through solving it. If I just show you the perfect solution all nicely, neatly written, you don't see kind of the mental struggle that one goes through to solve these problems. You have to make a draft, then make another draft, take out a separate sheet of paper, practice, try to figure out what's going on, and then you get better and better drafts as you do this. So now I can rewrite this. So these are the same exact steps as in the previous page. These same steps here are right here, but now I can rewrite this correctly. I know that this first step is a negative 7 degrees. So this is 0, this is 5, 6, 7. I know that that gets doubled. I know that you added 10 degrees and negative 10 degrees to that, or subtract 10 degrees, it gets 10 degrees lower. And I know that you add 40 degrees to this arrow to get here, which is a positive 16 degrees. So now I'm going to go through and I'm going to call these, I'm going to call this first step x. I actually don't know what that is just yet as I redraw this. I actually do know it's negative 7 degrees, but I'm going to call it x because I want to show you the algebra of how you solve this problem algebraically and how that matches this visual solution. So what happens to x? It gets doubled. So now you end up here, that's 2x right there. And so what happens to the 2x? You add a negative 10 degrees or you subtract a positive 10 degrees. So it's the same thing. So you're making it colder by 10 degrees. So I'm going to add a negative 10 degrees. So now I'm going to end up here. And then from this point, add a positive 40 degrees. I'm going to add a positive 40 degrees. And where do you end up? Right here. That number we know. That number is positive 16 degrees. So now, if I'm going to solve for x, and this is the point of these puzzles and of matching this visual example with the algebra, is you're going to do the same exact thing both visually and algebraically. So I'm at positive 16 degrees right here. So what happened to the positive 16 degrees is I had added 40 degrees. I have to subtract that 40 degrees to get back to here. So I subtract 40 degrees. So positive 16 plus a negative 40 degrees. That is the same as subtracting 40 degrees. So if I add a negative 40 degrees right here, this becomes 0, and you're left with 2x plus a negative 10 equals negative 24. So this point right here is negative 24. And so now how am I going to get to this point? I'm going to add 10 degrees. I had added a negative 10 degrees to go from here to here. I'm going to add 10 degrees to go back. That's what you do right here. If you add a positive 10 degrees here, this becomes 0. So now it becomes 2x equals negative 14, because this negative 24 plus a positive 10 gets you to this point right here, which is negative 14. And so now how did we get to negative 14? Well, this is 2 times the beginning temperature. So you have to then cut this negative 14 in half, divide it by 2 to get back to the beginning temperature. So if I divide 2x by 2, that leaves me with x. I have 2x of something. If I divide it by 2 or take 1/2 of that, that leaves me with one of those x's. And I have to take 1/2 of a negative 14. So half of negative 14 is negative 7. So negative 14 divided by 2 gets me to negative 7. So now if I just add these values in here, you can see what's happening. But the important point, the reason for doing this is to begin to learn the algebra, the steps in solving something algebraically. So now we're solving for this x algebraically. Now there are shortcuts, simpler steps that we could take, but now is not the time to do that. Now is the time to look at each step in the puzzle and trace that step algebraically, which is what we did here. So this is negative 7 up here. That gets doubled to negative 14. It's 10 degrees colder, so that's adding a negative 10 degrees to negative 14 is a negative 24 degrees. Then adding positive 40 degrees to end up at positive 16. So notice that if you add a negative plus a positive value, you subtract their absolute values. 40 minus 24 is 16, and it's a positive 16 because there are more positives than negatives. So you find that difference, you subtract their absolute values. And the absolute values is the value of each number without a sign. So there are 40 things here, of which you're going to take away 24 things, and you end up with 16, and those are 16 positives because you had more positives than negatives. So you end up at this positive 16. In the second problem, you are given comparable distances that people ran, and you're supposed to figure out how far Lynn ran in the end. So for example, Lynn ran twice as far as Diego. When you compare Lynn and Diego, Diego ran 300 meters farther than Jada. When you compare Diego to Jada, and Jada ran 1/3 the distance that Noah ran. And they have to give you some number from which to work to figure out, in this case, how far Lynn ran. And that number is the distance that Noah ran. Noah ran 1,200 meters. So that's the starting point from which you work backwards. Just like we worked backwards from 16 degrees in the last problem, we're going to work backwards from 1,200 meters in this problem to figure out how far Lynn ran. And so I drew an arrow diagram. Now, I don't know how far Diego ran, so I just drew an arrow. I do know that he started at 0 and ran a certain distance. So I just draw an arrow, and then what happened? Lynn ran twice as far. So Lynn ran twice as far as Diego. So just draw another arrow of the same length, and that's the distance that Lynn ran. And Jada ran 300 meters less than Diego. So just draw a shorter arrow, compare that to Diego, and this is going to be 300 meters less. And Noah ran 3 times as far as Jada. It says here that Jada ran 1/3 the distance that Noah ran. It's the same as saying that Noah ran 3 times farther. And Noah ran 1,200 meters. So now we can put a number to Noah, and then we can work backwards, just like we did the last problem, and figure out how far Lynn ran. So Jada ran 1/3 the distance that Noah ran. Noah ran 1,200 meters, so that's 1/3 of 1,200 meters. So how far did Jada run? She ran 400 meters. So this is 400. Well, that's 300 meters less than Diego. So if I add that 300 meters back to Jada's run, I know that Diego ran 700 meters. Jada plus 300 is 400 plus 300 equals 700 meters. And I know that Lynn ran twice as far as Diego ran. So Lynn ran 1,400 meters. So Lynn is equal to 2 times Diego. 2 times 700 is 1,400 meters. Now the point of these puzzles is to get to some algebra, to understand how you work through an algebraic equation. And so I'm going to make Diego x. That means that Lynn is 2 times Diego, or 2x. And that Jada is x minus 300. Diego's run minus 300. And probably the most the trickiest part of this, or the most complicated part of this, is understanding that Noah is 3 times Jada, and Jada is written as x minus 300. So 3 times x minus 300 equals 1,200 meters. This is a little bit harder here. We're going to use the distributive property to solve this. In a little while, we can solve it also without the distributive property. So if I do that without using the distributive property, I know that Jada's run is 1/3 this distance. This is 3 times Jada. So Jada is 1/3 of this. So 1/3, the multiplicative inverse of 3 is 1/3. 1/3 times 3 is going to make this 1. It's going to make this Jada's run. It's 1/3 of 1,200. So 1/3 of 3 times x minus 300 is this x minus 300 equals 1/3 of 1,200, or 400 meters. So we know that Jada, this is Jada now, Jada is x minus 300, is equal to 400. So now if I add 300 meters to this, this is going to make this x, which is Diego. So this is trying to translate this visual picture of their runs to the algebra. And this is what we want you to understand is, in the end, the algebra. How do you go from here to here and make some sense of it? So x minus 300 equals 400. So if I'm going to add that 300 back, I'm going to get back to what the value of x is. So that's 400 plus 300, so that makes this 0. If I subtract 300 and then I add 300 back, I get back to this value of whatever x is. And so x equals 700 meters. So x is 700, 2 times x is 1,400, and Jada is x minus 300, 700 minus 300 is 400 meters. And then Noah, of course, was 1,200 meters. Now we can draw a tape diagram of this. The authors actually, I think, prefer a tape diagram. I actually prefer this arrow diagram and working on a number line. But the tape diagram, might call this Diego, cannot do this, could do this not on the grid. I'm not really using the values on the grid, I'm just using the lines on the grid to make things neat. And so 2 times Diego is Lynn's run. And then Jada is Diego's run minus 300. So I'm taking off 300 meters off of Diego to give me what Jada ran. And remember that Noah is 3 times Jada's run. So I drew this, I could do this a couple different ways. I could just draw just Jada, just this part right here, and say 3 times Jada equals Noah. Or I could draw, this is Diego's run minus 300, which is the same as Jada. And I'm doing that for a reason. I want you to see different ways of saying the same thing. You could call Jada just this part, just labeled Jada, or Jada is also the same as Diego minus this 300. So we use that Diego minus the 300 in the algebra on the last page. So 3 times Diego's run minus 300, which is Jada, gets a little bit confusing, is equal to 1,200 meters. So the algebra, this is where I use the distributive property. So this is 3 times Diego minus 3 times 300. Here's the 300 right here that we're taking away. So it's 3 times this, call this a negative 300 if you want. 3 times this 300 is going to be subtracting 900 or adding a negative 900. Remember, it's 3 times Diego, so now we're at minus 900 equals 1,200. So now if we add this 900, we're going to get to Diego's run, 3 times Diego's run, and that's equal to 2,100. So now we've moved a little bit away from the drawing. It's not as easy to see the visual picture of what's going on. And that's where we're trying to get you to just develop a comfort level with the algebra. Yeah, I'm doing this correctly algebraically, and then later on you can check your answer. So this is 3 times Diego equals 2,100. So 3 times Diego, which is this Jada plus this 300. So 3 times this 300 is 900 plus 3 times Jada, which we know is 1,200. So this 900 plus 1,200 equals 2,100. That gets us to Diego's run. And 1/3 of Diego is equal to 1/3 of this total, which is 700 meters. So 700 meters for Diego, 2 times 700 meters for Lynn, and then 400 meters for Jada, which is Diego minus that 300. So this is a little bit tough in here. So I would go over this several times and think about what's going on. We're calculating this as 3 times Diego minus 300. So 3 times Diego is 3 Diego's runs minus 300, but 3 times. So minus 900, minus 300 3 times. That's minus 900. And so you have to add that to Noah's run to figure out what is 3 times Diego's run. And 1/3 of that is equal to 700 meters. Seems complicated to talk through it. It's actually not as complicated to just work through the algebra. So you should practice both.